Hello, folks. Welcome to the final lab of the semester with correlations and regressions. So I went ahead and made a data sheet for you all, and I'll make sure this is accessible. File. I can go to share. Share. Anyone link can be a viewer. Done. I'll put the link later up into the Blackboard shelves. So here we have our correlation and regression data. Now what we're going to do with this one is we're going to take a look at, well, one, our first objective is to calculate rates. So let's go ahead and do that. So we're going to calculate rates. In order to do this, we're going to just copy these 1, 2, 3, 4, 5 variables, paste it. Salt rate, alcohol consumption rate. I'm not going to put consumption on any of these. There's just going to be rate. So a rate, what a rate does is, as you recall in your data wrangling slides, it equalizes. It allows you to compare states with different populations or cities with different populations on equal levels. So, for example, comparing Alaska to California is just not the same comparison. It's just got literally 38 times more people in it. So we have here a way to compare this through rates. In order to calculate the rate, we go equal your number that you're interested in. Now the assault rate is actually true to data. The population is true to data too, and these things are random. The alcohol, heroin, cocaine, marijuana, those are random. But your assault rate, your assault count is true data, and so is your population. So our assault rates are actually going to be accurate. So this will show you safer places to live statewise. Whoever has a lower assault rate is the safest place to live. So let's just go ahead and take a look at where is the exact safest place to live. Your assault rate should also be multiplied by 100,000 because we're doing it per 100,000. Just go ahead and fix that. It looks like Alabama's pretty safe. Huh. Imagine that. But you double check this. Is that? Yeah, Alabama's really safe. Why is Alabama so safe? Limited data. Oh, so never mind. Alabama is limited data, so we're gonna flag this yellow because the people in charge of collecting data did not collect data. So anyway, moving forward, let's go ahead and calculate the rates for everything else. So equal alcohol consumption divided by population times 100,000. Okay, and we're just going to quickly calculate the rest by holding the population constant. So we'll lock population with a dollar sign and just drag it over. There you go. And now we'll just unlock each and every one of these and have it autofill. And autofill in the yellow marks too. I'll fix that. There we go. Let's go ahead and remove the yellow paint. Put this yellow paint back on. There we go. So now we have all of our rates calculated, like magic. No problem. And the next thing we need to do is to create a correlation matrix. Now your correlation matrix will be your variables of interest. In this case, we need a dependent variable, so our assault is interesting. We'll just look at them all. We'll look at the rates, okay? Assault rate. We should use assault rate, not assault. Apologies for that. So we'll go down here and paste. we're going to take this, right-click, copy, paste special, transpose, and it will do that. Now we're going to go through here and put ones diagonally because it's a 1-to-1 ratio, so assault rate is a 1.0 correlation with assault rate. Alcohol, these are the same thing, right? All the same thing. So let's go ahead and do alcohol consumption and assault. So coral, we're doing alcohol consumption. And assault. So 0.24. Okay. Now what we're going to do here, I'm going to copy this and just paste it there because it's the same thing. Paste special, values only. Heroin. Coral. So heroin and assault. You can do it in any order, so we're just going to do assault rate first. And then heroin. Enter. 0.24. Copy. Paste special, values only. Cocaine and assault. Equal coral. So we'll do the assault rate first. And then our cocaine usage rates. Remember, these are random, so they're going to be weird. Correlations are not going to be exactly true. Special values on it. Marijuana and assault. So let's go find marijuana. Comma. Assault. Enter. And we have that. Okay, next is heroin and alcohol consumption. It's equal coral. Heroin rate. And alcohol consumption. Very strong correlation on that one. Right click. So heroin rate, alcohol rate, paste special, values only. As you can see, it's the same thing. We're slowly filling this correlation matrix out. Next is cocaine and alcohol. This is probably really highly correlated in real life, honestly. Coral, cocaine, alcohol. Enter. Very high in this one, in this instance too. Paste special, values only. Marijuana and alcohol equal coral. Marijuana and alcohol. Right click, copy, paste special, values only. Again, just make sure you match them out. Marijuana, alcohol, marijuana. See, it's the same thing. Non-2, non-2. Next is, we got 3 more correlations to do. Is cocaine and heroin. So we can do heroin. And we can do cocaine. So this is how we are moving about so far. Making sure I'm recording still. Right click, copy, paste special, values only. Again, cocaine, heroin, heroin. See, matches up. We'll do this one next. This is coral for marijuana and heroin. Marijuana delete this one. Heroin right here. Enter, right click, copy, heroin and marijuana right here, paste special, values only, and now we got one more correlation to do, which is marijuana and cocaine. That's what I just do. Make sure here. And heroin and marijuana. That's correct. Okay. Just making sure I was correct on that. So let's do cocaine and marijuana. Cocaine. Marijuana. Enter. That's a very correlate. Base special values only. And there's our correlation matrix. This is how you make a correlation matrix. Okay. Remember that the lower correlations mean weak correlation, like this, 0.24. And higher correlations mean strong correlations, 0.90. And a perfect correlation is 1. Notice there's no 1s. And these can go negative as well. So a negative correlation being as one increases, the other decreases. And the positive correlation is they both go up together or they both go down together. That's just refreshing your correlation lessons. Now next we will move on to the regression portion of the lab. In order to do this, we need to go to our extensions and Excel minor analysis toolpack. Start that up. We're going to go down to linear regression. And our Y input range is going to be our dependent variable. In this case, it is assault rate. Make sure you include the labels. Click that. And then our dependent variables are going to be all these over here, all the other rates that we're comparing. Highlight them all, drag them all down, click in this box, tick your label. And our output range, we'll just put it just right underneath the correlation matrix, right here, and hit OK. This will generate a summary output after your computer thinks a bit. And we compare, let's go over this, okay? Multiple R, this is how everything's correlated, so it's everything all together, 0.32. Significance, F-test, so far, so good. And now let's take a look, all of our p-values. See, our p-values are, the model is good, okay? So the model works. So because the model works, we can go down here and look at these other ones. Okay? Anything below 0.05, we can reject the null on. This is above 0.5, 0.05, this is above 0.05. Nothing here rejects null hypothesis. So that's just out of the way altogether. These are all null hypothesis. They are not a confirmation of your hypothesis, in other words. So let's go here and look at the coefficient. Okay? So remember our dependent variable is assault. Now the model won't tell you what the dependent variable is. It just shows you what the independent variables are. So in this case, your coefficient says for every one assault, for every bit of alcohol consumption had, assaults go up by 6%. Okay. So, okay. Heroin rate goes up by 4.4%. You can see how this works. Let's switch it back to decimal view. So, a multiple of 0.04, or 4%. In other words, these drugs cause assault or release or relate it. You can say for every bit of alcohol consumption, assault goes up, again, 6% or 7%, 4.5% and 4.83%. But for marijuana, it actually decreases assault by 3.43%. That's how you read that, and the coefficient's the important one, right? So for your regression, coefficient and p-value. This is below 0.05, so we can reject the null hypothesis on the model. The model means your math is correct, okay? That's what the model means. For this, this is just saying the relationship. What this is saying is probably not enough sample size. So despite these findings, we have to basically ignore them. If this was below, let's say this was 0.01, right? Then that would be a reject of a null hypothesis, and this statement can be seen as scientific truth for the data model. But because none of the p-values came out to be reject null hypothesis, then we can't say any of this is scientific and finding. So that's how you do regression. Now take this lab, take the previous labs, and do the homework posted on Whiteboard now. Thanks for watching. Also, turn in your lab of what I just did, following along with this, to get credit for your lab participation this week. Have a good week.